Problem F6-1. Determine the force in each member of the truss. State if the members are in tension or compression. Please follow along in your textbook. There are 4 joints, labeled A, B, C, and D. There are 5 members, member AB, member AD, member BC, member BD, and member CD, which we are going to initially assume are all under tension. There are also 3 reaction components. There is the vertical reaction at A, and there is the reaction at C, which will have an X and a Y component. Members AB and BC are horizontal, which means that their tensions will act purely in the X direction. Member BD is vertical, which means that its tension will act purely in the Y direction. However, members AD and CD are diagonal, which means that we will need to take their tensions and break them up into components. One way to do that is to find the length of AD and CD. We can use the Pythagorean theorem. From the diagram, AD goes 4 feet in the X direction and 4 feet in the Y direction. Using the Pythagorean theorem, the length of AD is equal to the square root of 4 feet squared plus 4 feet squared, which is equal to 5.657 feet. Member CD has the same dimensions, so it will have the same length. Next, we will want to find the sum of forces equations for each joint. So starting with A, in the X direction, both AB and AD will apply force in the X direction. Both tensions will be pulling to the right, which probably means that both are not actually under tension, but again, we are going to assume they're under tension until we get an answer. Member AB is horizontal, so that tension pulls it purely to the right, so we can say just TAB. But member AD is pulling it diagonally, which means the horizontal component of force will be the horizontal component of the member length divided by the total member length. The horizontal component of the member length is 4 feet. The total member length is 5.657 feet. In the future, I am going to not say this step explicitly. I am just going to make this division. And 4 feet divided by 5.657 feet is 0.707. No unit. Which means the equation for the sum of forces in the X direction on member A, on joint A, can be written as TAB plus 0.707 TAD. In the Y direction, joint A has the reaction from A and D, the tension from member AD, and the reaction at A. So again, member AD is diagonal, so we will need to find the component. So that equation becomes 0.707 TAD plus RA is equal to 0. Moving on to joint B. The sum of forces in the X direction on B, there is member AB pulling it to the left and member BC pulling it to the right. So the sum of forces is negative TAB plus TBC. In the Y direction, there is just member BD. So the sum of forces on joint B in the Y direction is TBD. At this point, I am going to speed up my statements of these joint equations. Sum of forces in Cx, there is negative TBC, since member BC is to the left, negative 0.707 CD, it is going up and to the left, plus RCX, the unknown reaction X component at C. Sum of forces on joint C in the Y direction is positive 0.707 TCD plus RY. And on the D joint in the X direction, there is negative 0.707 TAD plus 0.707 TCD, plus joint D has that 450-pound load in the negative X direction, so that adds to a negative 450 pounds. And in the Y direction, there is negative 0.707 TAD minus 0.707 TCD minus TBD. So ignoring this first equation because we turned it into this equation right here, there are 8 equations and 8 unknown values. You can, if you want, use a simultaneous equation solver such as the RREF method. However, some things stand out which will make this problem a bit easier to solve. So I am going to solve this piecemeal. Now, when I solve using an equation, I am going to highlight that equation, which will help us remember which equations we have already used, and so we won't have to use them again. So first off, very obviously, this equation right here, TBD is equal to 0. That means that that member BD is not under any tension or compression. In an ideal world, we could remove that member and nothing about this structure would change. So first bit of information, TBD is 0. Now there are no other equations that we can do this with just yet. However, notice that the two sum of forces on D equations, if we know that TBD is 0, the only two unknowns left in these two equations are TAD and TCD. We can solve this as a system of 2 linear equations, 2 unknowns and 2 equations, which will give us the values TAD is equal to negative 318.2 pounds and TCD is equal to positive 318.2 pounds. We have used those equations, so I'm going to highlight them. So now we know TBD, TAD, and TCD. The only two unknowns left are AB and BC. So at this point, we have a few options we could take. Let's start with this one, sum of forces on A in the X direction. TAD is known, which means that TAB becomes the only unknown in that equation, and so we can solve for TAB there, which will equal 225 pounds. Finally, now that we know TAB, in the sum of forces on B in the X direction, TBC is the only unknown, so we can solve that. Now notice we have not solved using all of our equations. We have just solved using the 5 highlighted equations. But the problem asked for the tension or compression in each member. It did not ask for the reaction forces. We could, if we wanted to, solve for these reaction forces, but they would not be relevant to the problem. So putting it all together, TAB is under 225 pounds of tension. TAD is under 318.2 pounds of compression. Remember, TAD was negative, so negative means compression. TBC was under 225 pounds of tension. TBD did not have any internal force. And TCD was under 318.2 pounds of tension.